Welcome to the Math Record. Today we'll be introducing sequences and series in calculus. This video will cover part 1 of chapter 4 in our calculus class. Okay, let's begin. So what is a sequence and what is a series? Well, generally, a sequence is just a list of numbers, and this is usually in a pattern. In contrast, a series is basically a sum of these numbers. So, for example, let's say we have a arithmetic sequence of 1, 3, 5, 7, and 9, right? So it's arithmetic because it starts with 1 and it has a common difference of 2. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, right? So this is a sequence because that's just a list of numbers. So a series would be 1 plus 3 plus 5 plus 7 plus 9. That's 25. So this 25 will represent a series. So in definition, a sequence is just a list of numbers, 1, 3, 5, 7, 9, right? And a series would be a sum of those numbers in that sequence. So a series would be 25. And that's the general idea for sequences and series. Now, the follow-up question is, for sequences, is that how do we tell if the sequence converges or diverges? So those are two new words. Let's kind of define them. So convergence. So when we say something is converging, it means that it's approaching some kind of number. So it has a similar idea to limits, right? So let's kind of like use an example. Let's say we have a sequence f of n, and that is equal to 1 over n. Okay. So does this sequence converge or diverge? Well, let's kind of find out. Let's kind of list some numbers out. So what's the first number? So n is equal to 1. That's 1 divided by 1 is 1. What's the second number? Well, that's n is equal to 2, so that's 1/2. The third number, it was n is equal to 3, is 1 over 3. The fourth number is when n is equal to 4, that's 1 over 4. And etc., right? So it goes on for a while. Let's stop at like 1 over 5, right? So that should be good. 1 over 5. So does this sequence converge or diverge? Well, if you look at these numbers, you have 1, like somewhat big, 1/2, okay, it's getting smaller, 1/3 even smaller, 1/4 even smaller, 1/5 even smaller. So it looks like it's getting smaller each time. So it kind of shows like this pattern that it might converge. So convergence means that it's approaching like some value. But how do we tell that without even writing these numbers down? Well, what we could do is that we could use a limit. So we could have limit as n approaches infinity, and then we just put in the equation, which is 1 over n. So as n approaches infinity, what does 1 over n approaches? Well, it approaches 0, right? Because it's 1 over a big number. And as that number becomes bigger, 1 over n becomes smaller. So it becomes smaller and smaller and smaller. It turns into 0, right? So this kind of represents, if you kind of think about it, if n represents the term number, right? So if we have a lot of terms in here, and n is like our last term, right, which is an infinitely large group of numbers, then the ending term would be 0. And that's the general idea for convergence. If the ending number has a specific value, like a specific numerical answer, as it's a number, then it's going to be converging. So since the limit as n approaches infinity of 1 over n is equal to 0, and 0 is a numerical answer, then this sequence, 1 over n, is converging. So if the limit actually has a number, then it's converging. If it doesn't, it's diverging. So that the concept of divergence, right? The concept of divergence is anything that is not converging. So if it's like not going to a specific value, right? So if this limit approaches infinity or like negative infinity or like not an actual answer, then it's got to be diverging. Converging means that it's going to one specific number. So let's kind of like try something that's like diverging, right? So we have f of n is equal to -1 to the power of n. So how do we know that this is diverging? Well, we could use a limit, right? So limit as n approaches infinity of -1 to the power of n. So what is negative 1 to the power of infinity, right? Because n approaches infinity. Well, how do we know if it's like what number it's gonna like turn into? Because it either goes as a negative 1 or a 1, which makes sense, right? Because if you have negative 1 to like an even number, like to like 2, 4, 6, 8, 10, etc., right? It's just negative 1 times itself, which is just gonna be 1. Now, if you have negative 1 to the odd number, you're just gonna have like negative 1 by itself, right? Which makes sense because you have negative 1 to the power of 3, that's negative 1. Negative 1 to the power of 5, that's negative 1. So anything to the power of odd is negative 1. So since they have two possible answers, it's alternating between negative 1 and between 1 and negative 1. That means f of n, negative 1 to the power of n, is gonna be divergent because it does not converge to a singular number. Which makes sense because if you kind of draw a list of them out, what's the first term? Was negative 1. The second term is 1. The third term is negative 1. The fourth term is 1. The fifth term is negative 1. And if you keep going, it's just negative 1, negative 1, 1, negative 1, 1, negative 1, 1, right? So it continues on this pattern of negative 1 and 1. So since it's not like getting smaller to, or like getting bigger to like a specific number, like it ends at like a really specific number, then basically this sequence is diverging because it does not have a specific answer it like reaches. So let's cover one more example, and let's say that is f of n is equal to 1/2 to the power of n, right? 1/2 to the power of n. So is this converging or is this diverging? Well, to do this, we could use a limit, right? So as n approaches infinity, we have 1/2 to the power of n. So as you have, if you put infinity in here, it's 1/2 times 1/2 times 1/2 times 1/2, right? So if you have 1/2 and you take half of something, and then you take half again, and then you take half again, and you take half again, it's just gonna get smaller and smaller and smaller, right? So as the smallest possible number is 0, if you don't have negatives, right? But 1/2 is always positive, right? Which is just a geometric graph. So you kind of graph this out, it kind of looks like this, right? Makes sense because you have, oh, let's say 1 and then to 1/2 and then to 1/4, then to 1/8, right? So it's getting smaller and smaller and smaller. So that's the general idea of the limit. So if you have it, if it's getting smaller and smaller, and since that graph was reaching like some kind of number, right? It's reaching 0 because that's the smallest possible number that's positive, right? I mean, it's not positive. It's not positive. 0 is not positive or negative, but since 0 is an actual number, since it's reaching like a numerical answer, it's reaching some kind of number, then this tells us that 1/2 to the power n as a sequence, it's gonna be convergent because it has a numerical number. So if it has a numerical number, it's converging. If it doesn't, it's diverging. But if you have something like negative 1 to the power of n, which have two possible answers, it's also diverging because it does not converge to a specific number. So for it to be a converging sequence, it has to have a specific number, and it has to only be one. It has only be one specific number. So it has to be both conditions at the same time, right? So it doesn't matter what number it is, it just has to be a number, but it could only be one specific number. So it can't be negative 1 or 1. It has to be either 1 or it has to be either negative 1 or it's got to be 1. It can't be negative 1 or 1 at the same time. So let's try something similar that's similar to fn, is similar to 1/2 to the power of n, right? Let's say we have 3/2 to the power of n. So is this converging or is this diverging? Well, since we covered this one and we said this one's converging, right? So this one converges. Wouldn't this one converge? Right? Would this one converge? Well, spoilers, it basically does not converge because the reason is 1/2 is less than like 1, right? So if you have 1/2 and you take half of something, you take half something, it's always getting smaller. But we have 3/2. So if we have 3/2 of something and then we take 3/2 of something again, right? if you have 3 over 2 and you convert to a decimal, it's 1.5. And then you multiply by 1.5 times 1.5 times 1.5, right? So if you have 1.5 times 1.5, that's 2.25. 2.25 times 1.5 is 3.375, right? So it's always getting bigger. So 3 over 2 to the power of infinity, if you put in a limit, right? Yeah, limit as n approaches of infinity of 3 over 2 to the power of n, it's going to approach infinity because it's always going to get bigger. Since it does not have a numerical, it does not have a single numerical like a number that it reaches, then a limit, then basically 3 over 2 to the power n as a sequence would not be converging. So it'd be divergent. So this one is divergent. So it diverges basically. And that basically covers like convergence and divergence. So basically all you need to do is just set up a limit of that equation, and if it reaches a single numerical answer, then it's going to be convergent. So in the next video, we'll be covering more about series because in this video, we covered more about sequences. So that basically covers everything we have to teach for the introduction of sequences and series. Thanks for watching, and I'll see you at the next math record.